In this video we're going to know how to rewrite defined integrals in sigma notation for Riemann sum. Here we have a example, but before going to this, let's do a general big picture. When we have the integral from a to b of f of x dx, we saw in the previous video that this is equal to the limit as n tends to infinity of this summation. If we're talking from the right, Riemann sum will be from I equals 1 to n of f of x sub I delta x. Now, x sub I is equal to a plus I times delta x. Look, we have a function, whatever function it be. Well, if we want the area from here to here, yeah, we will do Riemann sum and whatever. It would be the summation from I equals 1 to n of f of x sub I. Now, f of x sub I begins, because this is a right Riemann sum, it begins, if this is the interval, the rectangles will be this one, next, this one, next, this one. This here wasn't very clear, but remember that because it's a right Riemann sum, is the right end point, the one that is touching the function. Our x sub 1 is this one. This is x sub 1. This is x sub 2, and this is x sub n. So our x sub 1 is x sub I, x sub I is going to be a plus I times delta x. That is, we are finding the defined integral from a to b. This is a, this is b. So the first term, that is x sub 1, is a, x sub 1 will be a plus I is 1 times delta x. So the first term was a plus the delta x, that is the width of the rectangle. So this is x1. Next, x sub 2 will be a plus 2 delta x. That is because a plus 1 delta x is this one, plus another delta x is this one, and this is x sub 2. So this is the summation. Here I'm not especially care about that we take the limit as n approaches infinity, because this is true even though we just have 5 intervals, that is the one that we're going to calculate now. So this is just the summation from I equals 1 to n of f of what's x sub I. X sub I is a plus I delta x times delta x. So for this one, we have the graph. Let's say the integral from pi to pi. This is pi. This is 2 pi. If we do right Riemann summation, the first rectangle will be this one. Next, this one. Well, it is very difficult to appreciate here. That is the right end point, that is the one that is touching. Here will be this one. Next, this one. Next, this one, etc. You already know how to do this. Alright, the point is how we write this in this form. We will have the summation from I equals 1 to n. N will be the intervals that we decide to put, of f of, what's a? A is pi plus I. What's delta x? Delta x is the width of each rectangle. So if the width of this sum of all rectangles is from pi to 2 pi, we have 2 pi minus pi, and we divide this by the rectangles that we have, that are n. So this is delta x. So our delta x is pi over n. So times pi over n times delta x. Now what's f of this? F is cosine x. So this is the summation from I equals 1 to n of f of, cosine of pi plus I times pi over n times, delta x is pi over n. So this is how we write this defined integral as a right Riemann summation. Remember that the traditional way for a right Riemann summation is when we have I equals 1. So from I equals 1 to n. If we want to write it in the non-traditional notation, will be the summation from I equals 0 to n minus 1 of cosine of, here remember that instead of having this, we have the summation from I equals 0 to n minus 1 of f of x sub I plus 1 delta x. So here, what is f of x sub I plus 1? So here we would have cosine of a x sub I sub 1. So here x sub I is a plus I delta x. So first we have, when I be equals to 0, when I is equal to 0, we would have f of x sub 0 plus 1. So it's again x of, this is f of x sub 1. So here we have cosine of a plus pi over n times I plus 1 dx, that is pi over n. This is due to, here I is now 0. So x1, here x1 is no longer just a plus 1 delta x. This is now a plus I plus 1 delta x. So x sub 1 would be, when I is equal to 0, because we are beginning from I equals 0, we have a plus 0 times, 0 plus 1 delta x. For x equal to 2, we have I is equal to 1, because we're in the second term beginning from 0. So when I is equal to 2, we have x sub 2 is equal to a plus 2, plus 1 minus 1 plus 1, yes, plus 2 delta x. X sub 3 will be a plus 2 plus 1, 3 delta x. So now our x sub, our x sub 1 is a plus I plus 1 delta x. Well, actually this is x sub I, because the x sub 1 is when I is equal to 0. So now our x sub I is a plus delta x times 1 plus 1, I plus 1. So for that, here we would have the summation of f of, it would be f of a plus delta x times a plus 1, and then times delta x. So for that we have cosine of a, a is pi plus delta x, that is pi over n, of I plus 1 times delta x, that is pi over n. So we rewrite this defined integral as the right Riemann summation with the traditional way, that is the summation from I equals 1 to n of cosine of pi plus I pi over n times pi over n, or in the non-traditional way, that is the summation from I equals 0 to n minus 1 of cosine of pi plus pi over n times I plus 1 all times pi over n. This is getting too long, so in the next video we are going to rewrite this one now as a left Riemann summation notation.